Hi, hello friends, welcome back to my channel. In this video, we shall learn one of the interesting, easy concepts from mathematics, that is matrices. Actually now, recent syllabus of SLC exam, they have removed this syllabus, but before when we were learning, this was there in the syllabus. So those days, this was the concept where we score easily the marks, okay? It's an easy concept only. Let's learn matrices. Before moving to the video, if you are new to the channel, please do subscribe and press the bell icon. Press all button so that you will get the notifications of all the videos we upload here related to Hstr exam 2022. And also these classes will be useful for TET exams, Central TET also. So as only few days are left for the Hstr exam, you are preparing, we know that. So we'll try to help out with few concepts, important concepts to cover up. Let's move into the topic now, matrices. Matrices is a plural form of matrix. A matrix is a rectangular arrangement of numbers arranged in rows and columns. Okay, you can observe here the matrices examples are given, and it is arranged in number of rows and columns. Here you can observe here, and this horizontal lines in a matrix are called as rows, and the vertical lines are called as columns. You can observe L here in columns L. So it is lengthy like this L. So you can remember in that way. If you are feeling difficult to remember the rows and columns, in column L it is vertical L it is. So these are the columns and these are the rows. And first matrix, when you take an example, here how many rows it is having? Only 2 rows and 1 column. Here 1, 2, 3 rows, 1, 2, 3 columns. Here only 1 row and 3 columns. 1 column, 2 column, 3 columns, and 1 row, 2 columns. So this is an example of matrices. Okay. We shall now learn about order of a matrix. In this matrix, you can observe there are 2 rows and 3 columns. So here order of a matrix is equal to number of rows into number of columns. So how many rows are there? 2 rows. 2 cross 1, 2, 3. 3 columns. 2 cross 3 is the order of the given matrix. Okay. It is read by, you can read as 2 by 3 also you can read it is. And the total number of elements in a matrix is equal to the product of the number of rows and number of columns in a matrix. So when you multiply the number of rows and number of columns, you will get the number of elements in a matrix. For example, 2 rows and 3 columns, 2 3s are 6. So how many elements are there? 1, 2, 3, 4, 5, 6. 6 elements are there. So by multiplying this two number of rows and number of columns, you can find how many elements are there in a matrix, how big the matrix is also you can find. Okay, so this is an example for order of a matrix. Let us now move to the types of matrices. Okay, so here I have not written the definition. I'll be explaining you orally so that you can, looking at the example given, you can understand. Hope so. Definitions will not be asked for the exams. They may give a matrix and ask you to identify. First one, row matrix. A matrix which has only one row is called as row matrix. So you can observe in this matrix only one row. Okay. So how do we write the order? 1 cross 3. So this is a row matrix. Okay. The elements could be of anything else. You can write as A, B, C also. Okay. Next, column matrix. Guess a matrix has only one column is called as column matrix. Here only one column. How many ever rows also you can write, no problem. So number of rows is 4 cross 1 column. So this is an example of column matrix. Square matrix. A matrix which has an equal number of rows and columns is called as square matrix. You see, 2 rows, 2 columns. 3 rows, 3 columns. So this is an example of square matrix. Next, on moving to rectangular matrix. A matrix in which the number of rows are not equal to number of columns is called as rectangular matrix. If it is a rectangle square matrix, number of rows will be equal to number of columns. Rectangle, which will not be equal. So here you see 2 rows and 3 columns. Here 3 rows and 2 columns. 2 cross 3 and 3 cross 2. So this is an example of rectangular matrix. Next, null or zero matrix. If each element of a matrix is 0, means all the elements must be 0, each element, then the matrix is called as null matrix or zero matrix. So you can observe here. Okay. Next, diagonal matrix. And before moving to the diagonal matrix, in case of a diagonal matrix, we observe the square also. Okay. So whenever we say plainly, it is understood that we are speaking about a square matrix. Okay. A square matrix which has all its elements 0 except the principal diagonal. So this is the diagonal here. You see, principal. This is also called as leading or principal diagonal. Okay, leading principal or principal diagonal. So here also you can observe only on the principal diagonal there are numbers, remaining all elements are 0. Here also only numbers on the principal diagonal, remaining elements are 0. So this is a diagonal matrix and it is a square matrix. Okay, all the diagonal matrices are square matrix, but not all the square matrix are diagonal matrix. Next, unit or identity matrix. Okay, we usually denote this unit matrix by I is equal to whatever the matrix we write here. The diagonal matrix in which each element of its leading diagonal is unit. Okay, unity means 1. You see here also one diagonal is of only 1, 1, 1, 1 here. Except that diagonal 1, 1, 1, remaining elements are 0. Here also you can observe. Even this side also you can take up. Okay, diagonal if it is. Remaining all elements are 0. Not the other elements. Okay, not numbers except zeros. Cleared? We shall move to the next type of matrix, that is scalar matrix. A scalar matrix is a square matrix in which all the elements in the principal diagonal are the same. You can observe here in this example, the elements in the principal diagonal are the same, and here the rest of the elements are 0, right? And moving to the next type of matrix, symmetric matrix. A square matrix is said to be symmetric if it is symmetric about the principal diagonal, or you can also say that the transpose of this matrix is equal to the original matrix. Okay, so here only square matrix can be symmetric matrix. You can observe here about the principal diagonal B, B, C, C, M, M, and it is symmetrical about this principal diagonal. And when you get the transpose of the matrix, means writing the matrix rows as column and columns as rows. Here you can observe A, B, C, and when you write that as this is a column and write as row as A, B, C, it is same, the transpose of the matrix. Next we will learn about the transpose of matrix also. Okay, then this is an example of symmetric matrix. About the skew symmetric matrix, it is almost same like a symmetric matrix only, but find out the difference here. You see, with the negative signs, right? So how do we define skew symmetric matrix? A skew symmetric matrix is a square matrix whose transposed form is equal to the negative of that matrix. When we get the transpose of this matrix and the negative of that. Okay, if there is a positive of this and you'll get the negative. Here positive, negative, negative, positive. Okay, so these are the major type of matrices. Next, we shall see about transpose of a matrix. If A is equal to, you see the elements are given 1, 3, 5, 0, 4, 7, the matrix. The transpose of the matrix is written as A dash, and we write this row as column, first row as first column, second row as second column. 1, 3, 5 you can write as 1, 3, 5 as column. Next 0, 4, 7 is written as 0, 4, 7 here as a column. So interchanging of rows and columns, we get the transpose of the matrix. Okay. Next, on moving to equality of matrices, if A is 2, 3, 1, 5, the elements are given, and B is also 2, 3, 1, 5 with the elements, then matrix A is equal to B we write. Means both the matrices must be of same order. You see, 2 cross 2. Here also the order is 2 cross 2. 2 rows and 2 columns, and the corresponding elements of both the matrices are equal. All the elements. If there is 2, 2, 3, 3 in the respective places only. We cannot have 2, 3 as here, 2, 3 as rows and columns. No. The corresponding elements must be the same in the respective places. Then we call these two matrices are the same, equal matrices. Next, we shall move to the concept of determinants related to matrix. The determinant of a square matrix is a computed single value which is computed from that matrix. It means from the given matrix, on solving this matrix, we get a single value. Okay. For example, matrix is given, A matrix, elements are A, B, C, D, and determinant of A you can write like this with the straight lines, and you can write the elements as it is A, B, C, D. And if it is just a square matrix like this with 4 elements here, you can directly solve it. Multiply A into D first, AD minus C into B. Okay, this is how we have to do. As we solve more sums, you will understand that in a better way. Let us check out with few sums related to determinants. It's very easy only, where you can sure of getting marks from this. Find the determinant of the matrix B is equal to 1, 2, 3, 4. A matrix is given. First step, you can write determinant of B and draw the straight lines. 1, 2, 3, 4 the elements, write as it is. Then if you find only like this 4 elements, you can multiply. What you have to do? First move down with the arrow mark. 1 into 4 is 4. With the sign we have to multiply. Then for the second one, minus of 3 2s are 6. Okay. And subtract from the bigger number. 6 minus 4 is 2. Put the greater number sign. Greater number is 6. So minus 2. So minus 2 is the answer. So on solving this matrix, we got a single value. Hence, this is the way of finding the determinant of the matrix. This is the value of determinant of the matrix B. Cleared? Next, find the determinant of matrix A is equal to 8, 7, 8 minus 3. So we write like this, determinant of A is equal to, and write the elements inside the determinant sign. Then multiply. First, we have to come down, move down like this. 8 3s are 24 with sign. Plus into minus is minus 24. Second, you have to put minus first. Then multiply. 8 7s are 56. Now we got here same sign. So you can add this 2 and put the same sign. 24 minus 56 gives minus 80. Okay. Be careful when you have a minus sign in the second case. Okay. First case you will usually do it. In the second case here, if you get the minus sign, you must be careful. Simple sums, but be little cautious. We shall find the determinant of this given matrix M. M is equal to minus 1, minus 2, 6, 3. Determinant of M is equal to, write inside the determinant sign and as it is. Now first one you have to multiply. Minus 1 into 3 is minus 3. Okay, 1 3 is a 3 with minus sign. Minus of, here you have minus sign. So already we have the common minus sign according to the rule, and 6 2s are 12. So plus into minus is minus. This is on multiplying this 2 we get the minus. Again in the next step, minus into minus is plus, that is 12 as it is. Then with one number with a greater sign, that is plus, and one with minus, you have to subtract. 12 minus 3 is 9. Okay, greater number sign is plus. Whether you write it or not, it is understood that it is plus only. If it is asked for descriptive type only, please write all this and explain. If not, you no need to take and write all this and waste your time. You can directly multiply this and you can solve. If you can do mind calculation is well and good. If not, you can just write this step and directly move to the next one. Okay. We shall move to another sum to find the determinant of the given matrix. Here find the determinant of the given matrix. Here 1, 3, 2, minus 3, minus 1, minus 3, 2, 3, 1. Matrix is given. So determinant of matrix, how do we write? Determinant of this matrix is equal to, with the determinant sign, we write all the elements. Again I am repeating, if it is for descriptive type, you can write this and explain. If not, you can directly calculate it. Okay, you can choose a number here only. And so there is an easy way to find if there are many elements here of 3 rows and 3 columns or more than that. Okay, BB rule we calculate, we use that BB rule. What is that BB rule? Cancel off below and beside elements, okay, for the chosen element. For example, as I explained, you will understand. First row, I choose only this first row to find the determinant. First one, 1, there is a number 1 here, so write the number 1 here outside. Then put the determinant sign. Next step, you cannot carry with the matrix symbol with the square bracket. You have to put the determinant sign. Then cancel off the number below the chosen number and beside the chosen number. Below the chosen number, all the number cancel, strike out this 2. Then what are the numbers left, elements left in the matrix? Only these elements are left. Tada, tada, you cancel. Minus 1, minus 3, 3 and 1. So minus 1, minus 3, 3 and 1. Finished. Choose the second one. Minus of, remember, first one will be plus, minus, again plus. So that is the rule here we have to use. So minus of the second number you have chosen, 3. Minus of 3. So cancel below and beside. Below, beside. You can also cancel the above elements. If you are choosing this minus 1, you can cancel above elements also. In general, I am just telling you this to remember. Okay. In the textbook and all, it is not mentioned as BB rule. Okay. Don't search for it. It just is my method of calculating, just to remember this. So cancel off below and beside numbers like this. For 3, I am cancelling this. What are the elements left? Minus 3, 2 and 1. Finished. Next for 2, plus number, plus 2. Below, beside, cancel. Minus 3, minus 1, 2 and 3. Finished. Then further you know how to calculate this. If it is given a chota, determinant inside only 4 elements are there, you know how to calculate. Just cross multiply. Minus into plus is minus. 1 into 1 is 1. So minus of 3 3s are 9 with minus sign. So minus into minus, again plus. If there is a minus sign here, you will get plus. Already we have to have 1 minus. So minus into minus is plus. Plus 9. Minus of 3. Minus into plus is minus. 3 1s are 3. Minus of 2 3s are 6 with minus sign. Again minus of minus is plus. Plus 6. Plus 2 of minus 3 into plus 3 is minus 9. Minus of this 2 1s are 2. Minus of 2s are minus into minus is plus. Plus 2 we got. Hence you can simplify further. 9 minus 1 is 8. Again minus 3. This you simplify. 6 minus 3 is 3. Plus 2. Minus 9 plus 2. So subtract the smaller number from the greater number. 9 minus 2 is 7. Put the greater number sign. Minus 7. Already we have learnt about all these basics in the previous videos. If you are getting confused, please check the description box for the number system chapter. We have already discussed in that video. Okay. Then on simplifying, 1 8s are 8. Minus into plus is minus. 3 3s are 9. Plus into minus is minus. 2 7s are 14. Then you can add the numbers with same sign. Minus and minus. You can add and put. Don't get confused here with multiplication. Okay. So minus 3 minus 14 gives us minus 23. So 8 minus 23. So you have to subtract from 23 minus 8. That is 15. Put the greater number sign. So these are the basics. Okay. So this is the answer. On solving the given matrix to find the determinant, when we find the determinant, we get the single value. So this is the way of finding. Cleared? We shall move to another sum to find the determinant of the given matrix. A is given. Here the name of the matrix is mentioned, that is A matrix. And determinant of A, plainly you can write like this. Determinant of A inside the determinant sign. And write the determinant sign, write the element as it is. Then we are choosing this first one, 2 4 minus 3. So we can write 2 outside. Cancel off below and beside. So we get only these elements, 8 6 7 9. Okay. Then second one, minus of 4. Below and beside cancel, we get 5, 6, minus 8, 9. Then plus of 3. So plus of 3, already we have minus 3 here. So minus 3, only 5, 8, minus 8 and 7. Okay. So by this time you would have learned this. If you are already know, you can just skip it and you can go and learn the other concepts. No problem. So those who still want to learn, you can continue this. So cross multiply, 8 9s are 72, minus of 7 6 are 42. Minus of 4 and cross multiply 5 and 9, we get 45. Minus of this, minus into minus is plus, so 8 into 6, 48. Minus 3, 5 7s are 35. Minus of minus, so plus 8 8s are 64. Again here we have to subtract, 72 minus 42 is 30. Then 45 plus 48, 93. 35 plus 64, 99. Then you multiply with all this. 2 30s are 60. 4 into 93. Plus, minus into plus is minus, 372. Next one, minus into plus is minus, 3 into 99, 297. Which is equal to 60. This two with same sign. So add and put the same sign. And next number, on simplifying, we get different sign. Numbers with different sign. Subtract 669 minus 60 gives 609 with a greater number sign, that is minus. Okay. So we have covered the basic points from matrices and determinants. I hope this will be sufficient for the exam. If you want for more practice, check out with the previous year question papers. If it is given, then you can practice for this. Okay. So if you like the video, don't forget to give a thumbs up. So as I told you, we shall continue few more chapters of physics, important points. I'm trying to take circles also, and few more concepts from mathematics, and if possible I'll continue with biology concepts, because biology concepts to write and explain it is difficult. So I'll find how I can bring out the best to you. Okay. So thank you for watching.